Okay, so I thought I'd do a quick video of creating a graphics converter, sort of mainly aimed at the Sam Coupe at the moment, but actually it could be used for any platform. Just involves adding the relevant parts. I tend to do most of my tools in C#, and trust me, fantastic tools make your life developing software much easier. I'm using Visual Studio 2022, the Community Edition here, so I'm just going to create a console app. I tend to do a console app because you can add it to batch files and bits and pieces like that, so you can make life a lot easier for yourself by scripting everything. Just means you can just hit build and away it goes and does everything for you. So we'll call this graphics converter. We'll use .NET just because it means I don't have to do so much writing, because we can use all the various elements of it. And let's bring that up on the screen so you can see it. Okay, so we've got our .NET program. Doesn't do very much. If we run it at the moment, it's on the fantastic, I'll bring the window up so you can see it. So presto, we can see Hello World, one's favourite app. Right, I'll make the text a little bigger. So, as I said, this is going to be a text-based editor. And so we're going to create just a new script file. Just want a plain old text file. We'll call this the advantage using a script-based editor. One, we can do all the editing. We can see exactly what's happening by hand. We can add lots and lots of extra commands in, and we can see what we're doing. I'll grab a text. I've already written a test script. I put it on Facebook actually. So this is the sort of script we're going to be using. The good thing is, if you want to, you can also write a full Windows or windowed editor. It doesn't have to be a Windows one. It can be on a Mac or Linux that can read these scripts and write these scripts. So you can do everything in a nice sort of drag and drop style editor, and it can export these text files. Also means you can then go and edit them by hand, and as I say, it also means you can make the conversion part of your build process. So it just makes life a bit easier. So basically all we're going to have is a system that can load in an image. Grab sprites, obviously quite important. Just put a few options in here. Notice I can't spell just. So I try and make everything as easy as possible for me. Sometimes I just want to grab the actual pixel data. We don't want to do any masking. Sometimes you might want to just grab a mask. Can be useful occasionally to do some strange effects. And if you're going to use the same mask on multiple sprites and try and save memory. We're also going to be able to grab mask and then data. So it will write a byte of the byte of mask data and then a byte of the pixel data, or the other way around, pixel data and then mask data. They're sort of the main ones I've used in on the Sam Coupe in the past. So our grab sprite is going to have a name, the type of data we want to grab. If we don't pass any details, it will just grab the entire image that's currently loaded, or we can pass in X, Y, width and height to grab specific chunks. Palette stuff, so the load image will grab a palette, but we can set specific palettes. We can also set named palettes. When we load an image, it's just going to grab work from the standard working image. We will have the option to grab that image, grab the palette out as a named image. I don't think I've put that in here. I've probably got it down further down. Nope, haven't got. Oh yeah, there we go. Grab palette. So I was going to have a grab palette that will take the current palette that's being used from whatever image was loaded and give it a name. So in this case, this would grab a palette and remember it under the name main. We can set specific entries. We can actually set colors on the working palette. and then we can write everything out. And there's later on we'll add some more fun little bits and pieces, so we can output binary, or we can output specific orders and everything else. But so this is the main function. So first thing we're going to need to do anything with this is we're going to need to create a new class. Because it's all running off a script, I'm going to create a new class. Oops. So this is going to be our script class. It's going to be very basic. Ooh, can't type today. Oh, really can't type today. So we're going to pass in a file name, and it will parse that text file and do whatever we want to do with it. So I'm going to open a stream for the text file. So I'm going to use the C#, the stream reader. I'm going to have a new one of those. And we'll get a file stream because we're going to be reading it from a file, not from memory. We're going to open an existing file, and obviously we only want read access. So that gets us access to the file. While we're not at the end of the stream, we will need to process all the lines. Now, the easy part is to read a line of text. So we can put refile.readline. Take the comment out. I think the problem is while I'm recording this, my machine, because I'm using 4K screens, the recording is slowing the machine down a little. So yeah, so we can just read a line of text, and if we really want to, we could just write that out in the console just to check we're reading it. We build that. What we will need to do is in our debug working directory, put it onto my projects drive, and it was in GFX converter and command line. Now we're going to need some command line arguments because we'll pass in the text file. So we're literally going to be passing in script. That should be all we need. Now, if we go back to our program, we don't really want hello world. So the first thing we'll need to do is I'm going to pull in all the arguments that we've just put in. Obviously there's only one. So these are the command line arguments. We get them from the environment. Oops. So that'll get us command line, just to do any sort of sanity checking. So command line args. Remember, command line args, the first one is always the program. So we want the program and the name of our text file. If we don't have it, we can just bail out after saying, oh, you got it wrong. Saves the program crashing. Then we want to create our script. So let's create, call it my script. And then we're literally going to call the parse function, and into that we actually want to parse command line 1. Not very exciting. If we run it, what we should see is it's basically just output the text file as we'd expect. That's fine. Probably one of the hardest parts of doing anything like this is parsing the actual script commands. So what we're going to do is we're going to have a new class for that. We'll create a class called script command, and into that we will literally just pass each line of text. And so we can now add a new. Machine does run very slowly while I'm recording. So we'll add a new class, script command. And as you saw, we need a constructor. And into that we are literally going to pass a line of text. Because the read line can return null, and just for safety, I'll using the string question mark to say we could technically be passed a null instead of a string. Obviously, we don't need to worry if the line is null. It's just a bit of extra sanity checking. So we only want to process if the line's null. Now, I've written various text parsers in the past. This isn't going to be a full function token one. If you've ever tried to write a C compiler or anything like that, or an assembler, it gets quite fun. But what we're going to do is want to pull tokens. So we will just have another function in here called parse token, and its job will be to pull out the next token in that line, because obviously we'll have the command and then we'll have all the various arguments that we're passing in. Actually, what we'll do, we'll want to store that. Oh dear, it's all going wrong today. We'll store the command in the class because we will need it when we get outside of this class. So now what we need is we will need a private function that returns a string, and it's called parse token. You'll notice that I have passed into this a reference to the string rather than the string itself, just because I specifically want to edit the string. As we're going, what we'll do is we'll pull off each command in and return what's out, and the string will be left whatever's left. So to parse a string, as I say, it's a bit of a pain. We're going to build up a token as we go along. Whenever you're parsing, white space is always a pain, so let's trim the line to begin with. That will remove any white space, space characters, tabs, things like that. And then we need to process the entire line. As I say, we're going to parse each character in turn. So we can get a character from the string. We know our line isn't 0, so we can just pull it off. Then there's various commands and ways of doing this, but effectively I've pulled the first character off the string and removed it from the actual string. Now, the easiest thing here is if this is a semicolon, we can actually break out. We're done. Need to return the token. Because as you'll see in the script, I'm using semicolon as a comment. So as soon as we hit a semicolon, we're basically finished. We don't need to do anything else. The biggest problem with parsing is we need to parse names. Because we probably won't want any spaces in these names. We could add something to check that, but certainly paths and things like that, we could have spaces in, because let's face it, people have folders with spaces in. So I've put it specifically so we've got quotes around them. I'm probably going to make this a little more tricky than it needs to be, because I might also allow us to have single quotes as well as double quotes. So what we're going to do is, because I've done this before, I've come across this sort of problem, I'm going to make it fairly simple. I'm going to have a string token, because if you needed, the reason you can use single or double quite often, later on we might want strings. I've got some ideas for, I think I've got something down here. Yeah, when we're generating assembly files, I was going to have a command that allows us to actually just write raw text out to the assembly file. Now, you might want to put a quote character into that, and obviously that becomes tricky. If this was a string, the usual syntax would be to put a / quote to say, I want to quote. The other option is you can use a single quote and then use the double quotes in the string itself. I know sometimes single quotes are for single characters and double quotes for strings, but this is just my preference. Because we can have multiple start strings, when we've come across, say, the double quote, we want to parse any text until we get to another double quote. Or again, if it's a single quote, we want to parse any text until we get to the next single quote. So what I'll do is I'm going to store a token which tells me what string token, what terminator I'm waiting for. We're not doing any sort of termination at the moment, so we will leave this as /0, 0. So the reason for this is obviously if we just left this code with a checking for a semicolon and then finishing, the semicolon could be in the middle of a string. We don't want to terminate at that point. It's not a comment at that point. It's just something within a string. So if our string token is null, so we're not reading an actual literal string, we can check for our semicolon. The other thing that will terminate, remember this is only parsing the first token, so it will come through and it will read the G, the R, the A, the B, the underscore, up until this point here. So until we get to another white space. So a semicolon would close it. A tab would close it, because that's considered a white space. You might not just put a space, you might put a tab to keep things looking neat. Another terminator might be a space. These are basically anything that means we have finished parsing our string. Comma, because if we've got arguments, we put commas between them, and the semicolon. I think that'll do for various things that can finish a token. At the end of our token, we either got a comment, we've got a space in tab, or we've got a comma because we're going to be moving on to another token. Now the tricky one. Handle strings. If what we have found is our string token, then we are at the end of the string. We could probably break here, because if you're parsing a string, that is the end of the string. I can't see any reason why you'd have something like some command and then you want to carry the command after the quotes. So we'll stick with that. If our string token again, if we're not parsing a string, but the token we've got is the start of a string, well, if this is the case, then we know we are now about to start parsing a string, and so this is where we set our string token to say keep going until you find the appropriate close terminator. Otherwise, we can add our token to the string. That should fairly much cover the parsing. I suppose what we could do is we could have a public function called getCommand. Okay, so script command, it will come in. Oops. Script command will come in, it will pass it in a line, it will parse the token, pull out a command. So at the moment, the only thing it will do is it will pull out the first command, but we can check that by, go back to our script. So this gives us our script command. What we can actually do is to write, console.write line. Give that a run. And there you go. You can see what it's done is it's pulled out. Obviously, these blanks are where we've got comments. What it has done is it's pulled out every command. We don't really want those blank lines, so let's just check. If let's try and type in treacle. So now we've removed all of the comment lines, so we're only worrying about the actual commands we need to use. Okay. Next thing we need to worry about is the arguments. So if we go back to our script command, up here, again, if there was no command, then there's no arguments for the command. So what we'll do is just do a check. One other thing I'm actually going to do here, because it will make our lives easier when we come to parsing them, I'm going to say all commands have to be uppercase. It just means if someone's putting lowercase, if you put random cases in your commands, it doesn't matter. We make the command uppercase. We know what we're using. Now, all we need to do, because we've got the line reference, that will have automatically changed as well. So basically, anything that's left on the line, we're going to assume our arguments. So we'll just ask it to parse the token again. So that will get us our next argument. If we find something, we need to store these. Best things to do. Let's just store them in a list. Good. And then we can do here, we can just add it to let's give a few access functions. So we'll have public get number arguments. I know we could put various .get, .set functions on the variables, but it's just how I tend to do things. A lot of my C# is very C based. It's old enough. That's what I do. The other things we want is we want to get an argument. Now, we need to be able to get some of the arguments are going to be strings. So we want to get argument. Let's call this get argument as string. I want an index. That's nice and easy because they're already in strings. But for like get, grab sprite and things like that, we pass x, y, width, height. Those are all going to be integers. So let's make life easier by putting the conversion information inside here. Otherwise, we're going to litter our code with bits and pieces to do string to integer conversions. So get string to integer, say which one we want. Now, to try and make our program not crash quite as much if people get it wrong, I'm going to use the try parse. And we'll get that. If we did parse it, it's good. We can return the value. If we didn't, let's return -1. I don't think the fact that in my office at the moment it's just below 10 degrees is making my fingers work quite as well with the typing. Because we want to sanity check the variables being, we don't want just, when we call grab sprite and we're handling it, we don't want to just blindly accept all the values are correct. What I'm going to do is I'm going to have a function called isArgument integer. And this is very much going to be the same as this. But we just want to return. So now we can get a number of arguments. So you see the parse token function is quite complicated in some aspects, but it becomes very useful because we just literally sit there and run through them. So what we can do now, check that works. We go back to our script command. We can write our command, and then we could say, it's very quick, sc.get number arguments. Get the argument as a string, just so it's easier to print. And we run that. What we should now have is our, there we go, we can see our parser is quite happily parsing. So with commands load, and we passed, that was the argument, grab sprite. There we go. So effectively we're parsing our script file quite happily, we're pulling out the commands, we've got all the arguments. So yeah, that makes that quite easy. Now, for the fun bit. I'm going to make this relatively modular. Splitting things up makes life easy, it makes it easier to follow. It makes all the single source files a lot smaller, which means you're not spending hours hunting through files to find out where things are, and hopefully it keeps everything tidy. The other reason I'm going to do what we're about to do is I could make it as a plugin system. So you could just write single little snippets of DLLs and drop into the folder and add new commands to the scripts without actually having to edit the original program if you wanted. So what we're going to do is we're going to have a command handler. So we're going to build up a library of functions with the appropriate command name. When we pull out a command, we look up, see if we've got a handler, and we call the handler to do the appropriate command. So this is going to be the base for it, and we're going to have a run. We'll pass in the script command. As this is the base, I could make it pure, but we'll just say turn false for now. So that's the base of my command handler. Let's have a new folder just to keep them tidy. We'll call these commands. Let's do one of these ones just to show how we're going to do it. Add a new item, and this. So each command would have its own source file. So the first one was load. So let's call this the load handler. Oh, don't want to put that in there. We could do, but namespaces, they can be a bit of a pain. So this is the load handler, and it's going to be from the command handler. And so we're going to override our run command for this. Ooh, it's already done all. That's nice of it. What we'll do in here is we will just do for now. And because we've got our command, we know we want to load whatever the first argument is. And we can return true to say we've done. Now, go back to our script. In here, we're going to need a dictionary. Dictionaries in C# basically like maps. It stores a key and a value. Our key is going to be the string, which is the command name, and the value is the command handler that processes it. Ideal. So this would just be a list of the command handlers. So down here we've got our commands. We don't need to write them out anymore, so we can get rid of that. Now, so we've got our command, so we can just say if our dictionary contains the key of the command, we can do something. If we don't know about this command because we've spelt something wrong or we haven't got a handler for it, we can simply say unable to handle command, so we can tell the user what's gone wrong. And just to make life easy, let's print the command. In here, we can then do command handlers. Again, get a command. Could have pulled that into a string, really, save all that typing, but it was fine. And then we want to run the appropriate command and pass in a value. Now, the only problem is we need to be able to set these handlers up. We could set them up in here, but directly, but let's, for ease, let's have a function called register handler, and this we pass command, and a command handler. And all we need to do to register is just trying to decide whether or not we should check whether we've already got one. But if you remember, when we pulled out the commands, we made them all uppercase. So let's do the same here. That way we know that they're going to match. We store the handler. And then back in our program, what we can do here, we just need now to register all our appropriate commands for our script. So we've got our new register handler. The only one we've got at the moment is load, and that is a new load handler. Presto. So give that a run. Presto. Now what we can see is we've run through the command, the load command, which we've given it a handle for. It can say, "Oh, loading." I know about that. So that's run our appropriate function here. So it said loading, and it's printed out in the file. Grab sprite, set palette, output ASM, all these it doesn't know about. We haven't written the handlers for those at the moment, so it just says tough. That's good. So it's doing now parsing. So we're parsing all commands. We've got a simple way of adding new command handlers. The only thing that would be nice is if we go back to our command handler. There's nothing worse than tools that just crash if you get something wrong. So let's have an is valid, just so we can sanity check what we're expecting is what we're expecting. Oh dear, really can't type in this column when I'm with these sluggishness. So we'll have an is valid option as well. So now if we go back to our load handler, what we will do here, again we will override the virtual. We don't want to call the base command. What we want to do here, we'll say that's true. The only thing we need to make sure that the number of arguments we've passed is 1. So if it's not equal to 1, we can return false. And then back where we run the commands in our script, rather than just blindly running it, we can say if command handlers. I'm starting to wish I'd taken that out into a string. Get the command is valid. So if it is valid, we can run our command. Oh no, we don't do anything in command man, that's what we're talking about. If we don't do that, we just need to say command has invalid number of parameters. And to make life easy to track it down, we could actually store line numbers as well, really. Feel free if you want to. Okay, and to check that works, if we were to go to our script and put (2) at the end of this, see if that works. Oops. Window back up so you can see it. Command has a number of parameters, whereas the one we haven't changed further down is fine. Good. Probably the next thing to create very quickly before we can actually get onto all the actual commands, we need somewhere to store all of the data that we're loading in and parsing. And so this is going to be all the data we want to export. So let's create a class to store it. First thing I'm going to want to store is possibly a bitmap. This is going to be the current image we loaded because we've got the load command, so let's use it. So this is the current image loaded that we are working with. Now, this is where, up to this point, the C# could be run on absolutely anything. This is where actually I make it Windows specific. I might have to change that just for ease for now. I'm just going to use system drawing. I'm going to use the system drawing functionalities that comes with it. I'm probably going to have to change this at some point because I know that this one, well, it's very useful and has a lot of very good functionality. It has palettes, but it doesn't have a way of getting the index of a pixel if it's in palletized form. It can only return RGB values. For now, that's fine by me because I tend to do true color for most things. And we will want a function. Let's have a function to load the image. Now again, we don't want it to crash, so this will throw an exception if it fails, so we have to put a try around it. Bitmap, because we're going to a bitmap. Bitmap. Let's create it from a file and pass it the file name. This is why I like the C#. You can circumnavigate a lot of things very quickly. As I say, we will probably have to change that one later. In here, we need to catch the exception. I'll just write a message to say load image failed. And let's just display whatever the message was, just so we get some idea of what's gone wrong. And let's clear the image. It shouldn't be anything in it anyway, but let's just make sure it's clear. And it helps if we then return false to say it's failed. In our script handler, one thing we're not doing is when we run command, we're not saying if the script fails. Right line to say command failed to run, and you'll get command again. So I think I've just hit caps lock. Command. Okay, that should check that. Now if we go back to our one thing we are going to need is we're going to need our export data. Let's store that in script. That's where all the commands are run from. So what we'll do up here is we will also have a private export data. And we're going to want to pass this into the run command because it's the commands that are doing anything. So we need to go and update our command handler to say we're passing in export data. And our load handler. This is why it's good that we've only created one because we don't have to go and change it in lots of places. Export data ed. And while we're in here, we can actually go. We can call our load image function. Get element string. If that doesn't work, we can turn false. Otherwise, we've loaded our image. So that's all good. What have we got wrong? Oh, this call is only reachable on Windows. Yes, because it knows C# is supposed to be portable, but it's not now because I've used a Windows-only library. For now, I'm just going to turn it off. So we'll just disable the platform check. I think that should do it. Okay. Loading for oh, it's because I haven't got an image. I need to go to the folder that we've created. It's up here so you can see it. Let's store our data in a folder called data. I'm going to just grab an image. Somebody might notice it from Treasure Island, is he? Hopefully that will now give us, yeah, so it's now managed to load the image. Right, I will leave it there. What we'll do next is, the next main part to do is to start pulling out sprites and palettes. As I say, I tend to work from true color images, so I'll start off by adding some functionality in to pull a palette apart. We'll also put a load of palette utilities, so being able to convert to and from RGB to Sam Coupe palettes and vice versa. Find the nearest match to a Sam RGB or Sam color from an RGB value, and things like that. When writing any graphics tools on the Sam Coupe, the palette manipulation is probably the worst bit. So we'll put in some help functions to do that, and then yeah, then we can start looking at a few of the other functions, and then we can put in our palette handlers and things like that. But I shall leave this video here, and yeah, I'll try and get on to the next one later on today or tomorrow.